everyone, welcome back to another episode in Java. Today I'll be teaching you all about double OP principles in Java. Today I'll teach you about inheritance, polymorphism, encapsulation and abstraction in Java. First of all, let's get started. First of all, I'll teach you about inheritance in Java. In Java, it is possible to inherit attributes and methods from one class to another. We group the inheritance concept into two categories. The first comes the subclass, which is also known as the child, and is the class that inherits from another class. And then comes the superclass or the parent. This class is the class which is being inherited from. To inherit from a class, you must use the extends keyword in Java. So, as I told you, there are two types of classes, subclass and superclass, child and parent. So, to inherit from a class, we must use the extends keyword in Java. Now, let's see an example code for inheritance. First of all, you go to src, select new and select Java class, and let's give this the name vehicle. And inside the vehicle class, we will have a protected string called brand. It's the brand of the car or the vehicle, and we'll call this Honda. And we'll have a method public void honk, and inside it we'll give an S out saying toot toot. Alright. What we did here was making a class named vehicle and adding a vehicle attribute string named brand, which was equal to Honda. And we made a method inside our class which will S out a toot toot sound or when we honk our Honda. Now let's see inheritance in progress. Let's make another class, class car extends vehicle. We have just now made another class named car which extends vehicle. This is an instance of inheritance in Java. We use the extends keyword to make our car class a subclass of our vehicle class or the superclass. And now inside it we'll have a protected string model name, which will be equal to Mustang. This is a attribute inside our car class. And after that we'll have a main method inside our car class, and inside it we'll make a object out of car. Car C equals new car. And after that we will call our object C, and we will print out our honk method from inherited from the vehicle class. And after that we'll S out our C dot brand concat space and C dot model name. Likewise, this is how we inherit from Java. From a class we inherited these attributes. Now we are going to print them and execute the method for our inherited class. So here we have two classes, one named vehicle, the other named car, which will extend to vehicle class and inherit like a subclass from the vehicle or the superclass. And now we have made an attribute named model name inside the car class, and we declared the main method, and we made an object of car class, and we implemented the car method honk, and we asserted the c.brand and c.model name. Now let's see the output for this example. Alright, we got toot toot Honda Mustang. That means our inheritance is successful. We inherited the toot toot sound from the vehicle class, and the car class implemented it and got the sound when honk toot toot. And it got the inherited brand name, which is Honda, and was concatenated to its own attribute Mustang. That's how inheritance in Java is done. Now let's see another example. If we made this string band private, what would happen? We wouldn't be able to access our brand inside our car class. So if we made this private, we wouldn't be able to access our brand from our vehicle class. So that's why we made it protected. Why and when to use inheritance? It is used for code reusability. Reusing attributes and methods of an existing class when you create a new class is what inheritance is. That means the code can be reusable in many ways, and we can reuse attributes, methods from an existing class or a superclass and use them in a sub or child class. Now what will happen if we made this vehicle class final? Let's check it out. If we made it private, we wouldn't be able to extend or inherit our vehicle class from our car class. So we should never use final when we declare classes, because they can't be inherited from another class when we made it private. So in that case we must use public to demonstrate classes. That's why we use public for the class vehicle. Now I have taught you about inheritance in Java. I hope you understood everything about inheritance in Java, like I explained to you. Now let's move on to another topic, another double OP principle in Java. Now let's learn about polymorphism in Java. Polymorphism means many forms. It occurs when we have many classes that are related to each other by inheritance. Polymorphism uses methods inherited from other classes to perform different tasks. This allows us to perform a single action in different ways. That means polymorphism is the ability of an object to have many forms. It occurs when we have many classes related to each other by inheritance. So polymorphism uses those methods to perform different tasks. This allows us to perform a single action in many different ways. Now we'll have an example for polymorphism. We'll have a class named animal, and inside the animal class we'll have a method. We'll declare method public void animal sound, and inside it we'll have an s out saying this is the animal sound. And after that, let's have another class, a class pig, and extends it to animal, and inside it we'll declare our animal sound method again, public void animal sound, and inside it we'll have an s out saying pig says piglet. And now let's make another class, a class dog, and extends it to animal, and we'll have a method in here as well saying public void animal sound, and inside it we'll have an s out saying bow wow bow wow. Okay, this is an example for polymorphism. We have made three classes. We have made a public class animal with a method animal sound which says this is the animal sound, and we have extended it to pig and dog classes, and we have implemented the animal sound method in both of the extended subclasses. In here we have an animal class, and the pig and dog classes have their own version of an animal sound which was there in the animal class. That's how polymorphism works. Now let's implement these methods and classes inside another class. We'll have another class named class main, and inside it we'll have the main method, and inside it we'll make an animal object, animal equals new animal, and we'll have another object, this time a pig my pig equals new my new pig, and after that we'll have a dog object as well, dog my dog equals new dog, and now we'll have our animal class to make the animal sound, and we'll make the my pig have an animal sound as well, and we'll make the my dog to have a animal sound. So in these different kinds of objects we have implemented the animal sound which differs from each one of them. So polymorphism is when objects take many forms and do actions inside our code which was their inheritance. Now let's run this and see our output. What do you think will be the output? Let's print it out and see the output. We got this is the animal sound printed, and pig says piglet printed, and bow wow printed from our dog class. So this is how polymorphism works. An object can have many types of forms, and when inherited from other classes we can use different attributes that look similar to another class's methods. That's how polymorphism works in Java. I hope you got a clear understanding of how polymorphism works in Java. Now let's move on to the next topic. Now let's learn about encapsulation in Java. The meaning of encapsulation is to make sure that sensitive data is hidden from other users. To achieve this, you must declare variable or attributes as private and provide public and get and set methods to access and update the value of a private variable. So that's what encapsulation is. It is making sure sensitive data is hidden, and to achieve this we make our class or variable attributes private and provide public getters and setters to access and update the value of private variables. Now we will have an example for encapsulation in Java. We'll make a class called person, and inside the person class we'll have a private attribute, private string name, and a private age, private int age as well. Now we have made these attributes private. That's the step in encapsulation. And now let's have getters and setters for our class. We go inside our class and we select generate and we select getter and setter. And now we must select all the attributes and say OK. Alright, we have made some getters and setters for our person class. As you can see here, there's a getter name, public string get name, and it returns name. And there's a setter called public void set name, which has a string name parameter, and it becomes this dot name equals to name. And later on we have public in get age, another getter which returns the age. And after that we have another setter which is public void set age, which has an int age as the parameter, and we make this dot age equals to age. So we have made our variables private and provided getters and setters for our class. That's the step in encapsulation. A getter returns the variable name of a attribute, and a setter assigns the parameter value to a new value and assign it to a new value inside our setter. Now we'll have another class. We'll have a class main, and inside it we'll have our main method, and inside it we'll declare a person object. We'll have person, person equals to new person. And now let's try to access our age or our name. We say person dot name. Oh, as you can see here, we can't access our name like that, or even our age. Why is this? It's because we made our attributes, our string name and int age attributes private. We have encapsulated, so we can't call our name and age by an object just like that. Now let's see another error. If we s out our person dot name and run this, what would happen? Let's see. We got name has private access in person. That means we can't use the name just like that by the object. So for this there's a different way. We can say person dot set age first and set our age. We'll give the age 17, and after that we can even set our name. We'll give a name like Alex, and to access these age and name values we can have an s out and print person dot get age and s out person dot get name, just like that. Now let's run this and check the output for our example. We got 17 and Alex printed just like that. That means our getters and setters and our encapsulation process successfully worked. So that's why we got our output like this. So why use encapsulation? It provides better control of class attributes and methods. And also class attributes can be made read-only if you only use the get method, or write-only if you use the set method. It's flexible as the programmer can change one part of the code without affecting other parts. It increases security of data. So encapsulation control attributes and methods and make them read only and write only, and makes it flexible for the programmer to change one part without affecting other parts, and it increases security of our data inside our encapsulation data. Well, now I hope that you got a clear understanding of how encapsulation works in Java. Let's move on to the next part. Now let's learn about abstraction. Data abstraction is the process of hiding certain details and showing only essential information to the user. It can be achieved with either abstract classes or interfaces. The abstract keyword is a non-access modifier used for classes and methods. Abstract class is a restricted class that can't be used to create objects. To access it, it must be inherited from another class. Abstract method can only be used in an abstract class, and it does not have a body. The body is provided by the subclass, which is inherited from the superclass. So abstraction is a process of hiding details. It can be achieved with abstract classes or interfaces, and the abstract keyword is a non-access modifier for both classes and methods. Abstract class is a restricted class which can't create objects, and an abstract method it can only be used in an abstract class, and it does not have a body. Okay, now let's dive down to coding. Now here is an example for an abstract class. We have made an abstract class animal, and inside it we have declared two methods. We can even declare abstract and normal methods inside an abstract class. In this we have a public abstract animal sound which returns void, and another public void method sleep which solves Z sound. That's what we have done in this code example. Now we'll have a class, main class, and inside it we'll have our main method, and let's try to access this abstract class animal. You say animal equals new animal, but we can't make an object out of our animal class, our abstract class, because it's abstract. Abstract classes can't be made by objects. Now let's have another class. This time I'll have a class pig, and it extends it to our abstract class animal, and we get an error line. To remove this error line, we click the red bar and we click on implement methods, and we'll choose the animal sound method and implement it. So we have got our pig class with an overridden method called animal sound. We can give an sout for our animal sound. We say sout and have a sound as piggy, piggy, piggy. Right, likewise. And now let's have another class. We'll have a dog class. Class dog. Class dog extends our animal abstract class. In here also we got our error. That means we must implement our methods from our abstract class. We choose our animal sound and we implement it. And now we have an overridden method and animal sound. Let's give a sound with a value for our dog animal sound. We say bow, wow, wow, bow. Now I'll make an object out of the pig class. You say pig, pig equals new pig. We can make it like that, and we'll have another dog object. You say dog, dog equals new dog, and let's try to access our methods from these two objects. We say pig dot, and we get our animal sound method and sleep method. We'll first implement the animal sound, and after that we say pig dot sleep method, and likewise for the dog we'll have our animal sound and our sleep method. Now let's run this and check our output for our pig and dog objects and methods. Okay, we got our pig sound piggy, 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 and its sound when sleeping zzz, and the dog's sound bow wow, bow wow, and its sleeping sound zzz, zzz, from this example after coding. Why and when to use abstract classes and methods? It achieves security. It hides certain details and only shows the important details of an object. That means we can use abstract classes and methods for security to hide certain details and only show the important details of an object. Likewise, I have now discussed about abstract classes and abstract methods. And in this full lesson, I have taught you about 4 OOP principles: inheritance, polymorphism, encapsulation, and abstraction. I hope you got a clear knowledge about these OOP principles: inheritance, polymorphism, encapsulation, and abstraction. Hello everyone, I welcome you all back to another episode in Java. Today I'll be teaching you all about inner classes in Java. Inner class means one class which is a member of another class. There are basically four types of inner classes in Java. Nested inner class, method local inner class, and anonymous inner classes and static nested inner classes are inner classes in Java. So basically, an inner class means a class which is a member of another class. So there are basically four types of inner classes. First is nested inner class, the second one is method local inner class, and the third one is anonymous inner class, and as well the fourth one is static nested inner classes. Now, in the first step, I'll teach you about nested inner classes in Java. Nested inner class can access any private instance variable of our outer class. Like any other instance variable, we can have access modifier, private, protected, public and default inside our inner class. Now, we'll have an example of an inner class. We say class outer, and inside we'll declare another class called class inner, and inside it we'll have a method public void show, and inside it we'll have an sout saying this is the inner class. Alright, we have made a new class called outer, and inside it we have declared a class named inner, and inside the inner class we have a method called show printing out this is the inner class. Now let's see how to access this inner class method. We'll have another class main, and inside it we'll have our main method, and inside the main method we say outer dot inner in equals new outer dot new inner, and now we say in dot show. This is how we access our inner class from the outer class. We say outer dot inner in equals to new outer dot new inner, and after that we access our show method by using in dot show. Now let's run this and check our output. Okay, we got our output. It says this is the inner class as expected. That means the inner class inside the outer class printed the show methods s out this is the inner class. Now we'll have another example. We say class outer, and inside it we'll have a method void outer method, and inside the method we'll have an sout saying outer, and inside our outer class we'll have another class, an inner class, and inside it we'll declare our main method, and inside it we'll have an sout saying inner, and let's try to run this and check the output. We can't run this because we can't have static method in a nested inner class, because an inner class is implicitly associated with an object of its outer class, so it can't define any static method for itself. That's why we can't run this output. I hope you got some clear knowledge about nested inner classes. Now let's learn about method local inner classes. Inner class can be declared within the method of an outer class. So let's check an example for this. We have a public class outer and a void method outer method, and it prints out s out saying outer. Inside it we'll declare another class inner, and inside it we'll give a method void inner method, and inside it we'll give a s out saying inner. And now let's try to access our inner class inside the method of the outer class. We say inner in equals new inner, and after that we say in dot inner method. Now let's have another class. We'll have a class main, and inside it we'll have our main method, and inside it we say outer out equals new outer, and after that we say out dot outer method. Now let's print this out and check the output for our sample code. We got outer and inner both printed when we ran this. That means the method local inner class worked. The class outer method had an inner class declared, which had a method called inner method which prints inner, and we made an inner object inside the outer class, and we said in dot inner method, and inside another class with the main method we accessed our outer class by making an object of the outer class, and we said out dot outer method. This ran both the outer method and the inner method, so it printed outer and inner. That's what happened inside this code. Now we'll have a int x inside our outer class's outer method. We'll declare int x equals 98, and let's try to access it inside our inner class's inner method. We'll say x is plus x. Now let's run this and check the output. We got outer and x is 98 printed. That means we can access our int variable x inside our inner class's inner method. That's why we got outer and x is 98. In previous versions of Java, you can't do this. You have to make this int x final. That's how you can access it inside the inner class. So now let's see what will happen if we made this final. So let's run this and check the output. We got outer and x is 98 printed this time also. That means final int x was printed inside our inner method. That's what happened. The main reason we need to declare a local variable as a final is that the local variable lives on stack till method is on the stack, but there might be a case the object of inner class still lives on the heap. Method local inner class can't be marked as private, protected, static and transient, but can be marked as abstract and final, but not both at the same time. Now let's learn about static nested inner classes. First of all, we will have a class outer, and inside it we will declare a public static void show outer, and inside it we will have an sout saying show outer, and after that we will have a static class inner, and inside it we will say declare our main method, and inside it we will have an sout saying inner out inner, and after that we will have our show outer method printed here. This is an example for a static nested inner class. Let's see the output when this is printed out. We got inner and show outer both printed when we ran this code. So this is an example for static nested inner class. Static nested classes are not technically an inner class. They are more like a static member of the outer class. So we have made a class named outer here, and inside it we have a public static void method show outer, which prints an sout chain so show outer, and inside the outer class we have static class inner, which declare the main method and it prints out inner, and the object show outer of the method show outer of the outer class. I hope you got a clear understanding about static nested inner classes. So let's move on to the next topic. Now in the next step we'll learn about anonymous inner classes. Anonymous inner classes are declared without any name at all. They are created in two ways. I show you the first way, as a subclass of a specified type. First, let's have a class demo, and inside it we'll have a void method show, and inside it we'll type an sout that says I am in show method of super class, and after that I'll have another class flavor demo, and inside it we'll declare static demo d, which will be new demo, and inside it we'll have a void show, and after that we'll have an sout saying I am in flavor demo class, and after that here we'll have our main method, and inside it we'll say d.show. So here we have made an anonymous inner class. Here we have made a class demo with the method show which says I am in show method of superclass, and we have made another class called flavor demo, and inside it we have made our anonymous class inner class. We have said static demo d equals new demo, and we have overridden our show method of the demo class, and inside the show method of the overridden show method we have a sout saying I am in flavor demo class, and after that I have declared the main method to print the dish.show method. Let's see the output for this code example. We got I am in show method of superclass and I am in flavor demo class printed as the output when we ran this code. And in the next step, we can have an inner class as an implementer of the specified interface. First of all, let's make an interface. Interface hello, and inside it we'll have a method called void show. And after that, we'll have another class flavor demo, and inside it we'll have a static hello which will be static hello which will be and which will be equals new hello. And after that we'll have an out inside our show method saying I am an anonymous class. And after that we'll have our main method, and inside it we'll say h.show. Now we have shown the next way to implement an inner class, an anonymous inner class. Now let's run this code example and check the output. We got I am an anonymous class printed. That means our second way worked and our anonymous inner class was created perfectly. In the previous code, we created an object of an anonymous inner class. But this anonymous inner class is an implementer of the interface hello. Any anonymous inner class can implement only one interface at a time. It can either extend a class or implement interface at a time. So now we have learned about anonymous inner classes in Java. We have learned about the 4 inner classes in Java, and I have taught you everything about inner classes in Java. We have learned about nested inner classes, static nested inner classes, method local inner classes, and anonymous inner classes as well. So that's it for today. Hello everyone. Today I brought you another lesson in Java. Today I'm going to teach you about enums in Java. An enum is a special class that represents a group of constants, like unchangeable variables like final variables. To create an enum, we use the enum keyword instead of a class or interface keyword and separate the constants with a comma. Note that they should be in uppercase letters. So, an enum is a special class that represents a group of constants which are unchangeable variables like final variables. We create an enum by using the enum keyword instead of a class or interface keyword and separate the constants with a comma. Note that they should be in uppercase letters. Now let's make an enum. We go to src, select new and select Java class. After that, without giving a class or an interface, we must choose enum. And we'll give a name for our enum. We'll give it the name level. And inside the enum, we'll have some constant final variables. We'll have low separated by a comma and medium separated by a comma and high. Now we have made an enum. We can use this enum to print out low, medium and high. Now let's print this out inside a class. We'll have a class main, and inside it we'll have a main method, and inside it we'll have level my level equals to level dot height. Now let's print this out. We'll print out my level. What do you think will be the output? Let's check it out. We got high. That means the enums high variable was chosen when we ran this. We chose level.high, so we got high. Likewise, let's check the others. We'll give here low. Now let's run this and check the output. This time we got low. That means it's fully functioning and the enum is working perfectly well. Now let's change this to medium and run this. We got the output medium right now. That means our enum levels medium constant was printed when we ran this code. An enum is a short term for enumerations, which means specifically listed. Now let's see an example of an enum inside a class. First of all, let's remove this and we'll have a class. This time we call the class main. Now let's try to make enum inside our main class. We'll say enum level, and inside we'll have low separated by commas and medium and high. Now we have made an enum inside the class. Let's try to print out the enum inside the main method. We'll say level L equals level dot high low. Now let's print this out inside our sout. We'll print out L and see the output. We got low. Just like in the previous case, we can use an enum inside the class. That's the main thing you need to know about from this point. An enum can be made in a class and it can be accessed inside the main method of a class. Now let's see our level enum in a switch statement. We'll have a switch right now. We'll say switch and inside it we'll give our enum L, and after that we'll have our case called case low. For that we'll give a sout inside it saying low, and we'll give a break as well. Next we'll have our case medium, and inside it we'll give an sout saying medium. And for this also, let's give a break. And now let's see our case high. And inside it also, we'll give an sout saying high. And after that also, we'll give a break. And now for the default case, we say default and give an sout saying default. Now we have made a switch for our enum. Now let's print this out and check the output. We got high. That means level.high was the enum level.high was printed in this case in the high case. Now let's change this to medium and print this out. We got medium printed as expected. That means our medium enum was printed in the case medium when it ran the code. Now let's make this low, level.low, and let's print this out and check the output. We got low. That means the switch case low worked and we got the enum low printed when we ran this code. Enums can be used in switch cases as I explained to you. I hope you got a clear understanding about enums from this lesson. The enum type has a values method which returns an array of all enum constants. This method is useful when we want to loop through the constants of an enum. That means there is a values method for enums which returns an array of all enum constants, and this method is used to loop through all constants of an enum. Now let's see this in progress. We'll have a for loop that says level le and colon level dot values, and after that inside we'll have our sout and let's say le. Now let's print this and check the output. We got our enums printed in the output. Low, medium and high were printed when we ran this values method in enums. That's what happened here. Now let's learn the difference between enums and classes. An enum can, just like a class, have attributes and methods. The only difference is that enum constants are public, static and final, unchangeable, cannot be overridden. An enum can't be used to create objects and can't extend other classes, but it can implement interfaces. Why and when to use enums? Use enums when you have values that you know aren't going to change, like month, days, colors, deck of cards, etc. The difference between enums and classes is that enum is just like a class and have attributes and methods. The difference is an enum constants are public, static and final and unchangeable and can't be overridden. An enum can't be used to create objects and can't extend other classes but can implement interfaces. We use enums when we have values that we know will never change, like month, days, colors, deck of cards, etc. Now let's see another example for our enums. We'll go to src, select new and select class and select enum and give this class enum the name RGB. And inside the public enum RGB, we'll give values red separated by comma, green separated by comma and blue. Now we'll make another class and we'll name this main, and inside it we'll have our main method. And let's try to access our RGB class, RGB enum, RGB as equals RGB dot blue. Now let's print this out and check the value of R. Now we got blue as the output as expected. Now let's have a for loop to declare all the values of the RGB enum. We say for and say RGB and give k and colon RGB dot values. And likewise after that we'll have an S out and we'll print out k, the values of k. Now let's run this and check the output. We got all our colors, RGB colors in the enum, red, green and blue printed out in this output, in this example. I think you got a clear understanding about enums from my lesson, and I think you will work with enums in the future. I hope to see you in another video another time. This is the end for this lesson, and let's see you in another lesson another time. Till then, goodbye guys, and please take care.